This is a new transmission from Rescue Shuttle Control. We're very encouraged by the information that we're getting from your downlink. It looks as though you're making excellent progress in not only controlling but modifying the power generation on your craft. And you're making good progress towards reactivating all your vital systems. Unfortunately, there's something new that's come to our attention that we need to be concerned about. It seems that we may not be the only ones monitoring your transmissions. We have indications that there are unknown beings who are following what you're doing and may be interested in breaking into your systems and perhaps taking control of your craft. For that reason, we need to spend some time concentrating on ways of making your systems secure. We need to work on being able to encode and encrypt and make it difficult for any unknowns to gain unauthorized access to your craft. So today we're going to learn some new techniques and some new methods that are going to be relevant to that task. We will be exploring one new hardware item that we haven't seen before and several new software concepts that we'll be using in our coding that will be useful to us for the purposes of enhancing security and for our other tasks that lie ahead as we get your shuttle up and running again. We'll start by talking a little bit about the new hardware item that you can see over here. You'll see that we have now connected to our hero. For the moment, we're not using the breadboard, but we have it connected to a keypad. And you'll notice that this keypad consists of 16 push buttons. We can push any particular button, and that will communicate with the hero through this ribbon cable. I'll point something out about this keypad. The keypad does consist of 16 switches in a 4x4 array. At first, you might think it would be necessary to have 16 separate wires connected from the keypad to the hero in order to be able to monitor activity on the keypad. But that's really more than is necessary because we can specify any given switch by just saying which row and which column it is in. So really, since there are 4 rows and 4 columns, we only need 8 wires, not 16 wires, in order to be able to tell the hero which button has been pressed. So that's what we've done. If you look in your supplies, you'll probably find a collection of these ribbon cables, which you can separate and get a group of 8 in this case that you can use to plug in, as you see here, on one side into the keypad and on the other side into the hero. Now, I'll point out as you are hooking yours up in this way that while we can hook these up in any order that we want, we've tried to hook them up in a way that is easy to trace and will generate the least possible confusion. So we've gone from the uppermost pin on the keypad to the uppermost of this row of pins on the hero. We've chosen to use pins 2, 3, 4, 5, and 6, 7, 8, and 9 as the pins that we'll be using on the hero to detect the activity on the keypad. As you'll see, and as you can perhaps see by looking closely here at the keypad, the 8 pins on the keypad are labeled C1, C2, C3, C4 in the upper part, and R1, R2, R3, and R4 in the lower part. The R refers to row, and the C refers to column. So that will be something for us to remember as we're coding to use the information coming into these pins. So as we've chosen it right now, we have, for example, row 1 corresponding to pin 2 on the hero, and so on. Now, the hardware that we've just introduced, this new set of keypad switches, we're going to need to have software that will communicate with this new hardware in a way that's useful to us. And this is not surprisingly going to require some new functions. Now, what we're going to introduce right now is something that's very useful to us in general. You've seen in some of our previous projects and some of our previous exercises that it's sometimes useful to write a custom function. And that custom function then can be called repeatedly in order to accomplish some task that we need to do more than once. Taking that idea a step farther, there may be some extra functions that have already been provided by some other developer. And we can make use of those by importing them into our coding environment. What we say is that these are library functions. And if those libraries have been made available to us, have been published, we can include them in our environment, and that will allow us to use them for our coding and not have to write it ourselves, not have to invent everything from scratch. That's what we're going to do now with the keypad, because it turns out that we have access to a keypad software library. So we'll take a moment right now to show how to acquire access to that keypad library and what it looks like in our code. If we turn our attention to the code window right now, we will see that the empty code that we have right here with just this setup and the loop has nothing defined at the top yet. However, if we turn our attention to the tools window in the controller for the Hero Arduino, we'll see that under Tools, we see there's an option called Manage Libraries. So I'm going to select Manage Libraries. Now, if you have not previously accessed the keypad library, then you'll need to take these steps. If you've already accessed it and it's already resident in your environment, then you won't need to do this. The libraries that are available are organized here in alphabetical order. You can see I'm in the A's right now, but I want to scroll down in the alphabet to get to the K's, because that's where I'll find. Here we go. We're in the K's, K-E-L, K-E-R, K-E-Y, and here it is, keypad. You'll notice that right now, this indicates that keypad has already been installed. So this was not necessary for me to do. However, if you have not previously installed keypad, you go ahead and hit install here, and that will give you access to the keypad library. So I'm going to go ahead and close the library manager so that we can now return here to our code window, and let's go ahead and include the keypad libraries, and they'll appear in our code. So I'm going to come up here under Sketch. I'm going to select Include Library. And under Include Library, if I go down to the bottom, I see an option, and that is Keypad. So once I select Keypad, you'll notice that we have some new statements that have appeared at the top of our code window. These include statements tell us now that the keypad libraries are available to us. From this point on now, we can use the specific functions that we didn't write but have been provided to us for the control and reading of the keypad. Now, the next thing that we're going to do is talk about some new variables that we're going to need to use in order to control and use the keypad. We've so far seen things like ints, integers. We've seen double precision, floating point numbers. We're going to encounter some more types of variables today that will be useful to us. For example, I'm going to include right now a couple of constants. I guess that's sort of an oxymoron to say that it's a constant variable. But these constants have a fixed value. We're going to be addressing a keyboard that has 4 rows and 4 columns. And so we're going to use rows and columns to denote those 4. You might think, well, why don't I just use the number 4? And that would be fine if we're never going to use this code with a keyboard of a different size. But since we can change this, the definition of rows and columns to other numbers, this is a nice way of keeping our code understandable. You'll notice that this is a constant, that is, its value doesn't change, and it is a byte, which means that it is a short number, a short integer, and that short number is all we need in order to hold the number 4 here, which is a small number. All right, the next thing that we're going to do is we're going to talk about the concept of an array. So what we have, for example, is in our keypad, we have 4 different rows and we have 4 different columns. We might be able to say, well, I'm just going to create a number variable that will correspond to row 1, give it a name like row number 1, and another variable for row 2, and so on, so that I would wind up with 8 different numbers. A less cumbersome and cleaner way of doing this is to come up with a single variable that has separate entries to it. This is what's called an array. So I'm now going to introduce an array for rows and an array for columns, and we'll define those at the top of our code window here as well. So these are type byte. They're not constants anymore because we would like to be able to change them, but they could be. The first array is row pins, and the second array is column pins. Each of these is a set of 4 different values, and you can see that the 4 values that correspond to rows are 5, 4, 3, and 2. These are going to be the hero pins that correspond to those 4 rows. Likewise, the 4 columns on our keypad will be connected to the hero pins 6, 7, 8, and 9. And in a few minutes, we'll verify the correctness of those numbers, and we'll explain why they have the values that they do. Before I move on from this subject of arrays, however, I need to point out something rather important. And maybe the best way of doing that will be to give you a little example here. One of the functions of the declaration that we made here at the beginning of our code block was just simply to define row pins and column pins as variables known to our program. But we've also taken the opportunity here to initialize them to their initial values, to 5, 4, 3, 2, 6, 7, 8, and 9. You might think, well, couldn't we have done that in setup? We could have. And if we chose to initialize them in setup, we might put in values looking like, statements looking like this. Row pins of 0 equals 5. Row pins of 1 equals 4. Now, the reason why I brought this up was I wanted to point out something very important to you. And that is, although different programming languages have different conventions, In this programming language, the first element of an array is not element 1, it's element 0. So that's the reason why the value of row pins of 0 is equal to 5, and it's not row pins of 1. And likewise, the largest value here is not 4. The largest index here is not 4. The largest index is 3. So as we go from 0 to 3, the values are assigned are 5, 4, 3, 2. That's something pretty important to remember because it's quite easy, if you forget it, to have your array indexes be off by 1. I'm going to go ahead and erase those though because they're redundant. We've already defined our values for the row and column pins in the declaration up at the top. All right, since we've now seen the concept of arrays, we're going to take that just another step farther, and we're going to introduce an array of arrays. A way of thinking of this is as a two-dimensional array. Let's go ahead and see what that might look like. What I want to do here is I want to introduce a label, if you will, for every one of the buttons on our keypad. That's going to be 16 separate labels. And these are going to correspond to the character that we want to send when we press that button. So let's go ahead, enter that into our variables here and see what it looks like. There are a couple of new things for you to notice here. Instead of there just being one dimension to this array, as we had up here, rows and columns, this array, called buttons, has two dimensions. It's 4 by 4. So the first 4 elements, that is the first row of this array, we're entering in the characters 1, 2, 3, and A. Likewise, in the second row, 4, 5, 6, and B. And so on down the line. If you wanted to think of this in terms of columns instead of rows, you could simply jump from the first row to the second row to the third row and so on. And so you could see that, for example, column 1 would be 1, 4, 7, and star. So hopefully what you can see here is that we have now associated each button on our keypad with a typed character. And that raises another point that's worth mentioning here. These are not bytes, these are not ints, these are characters. And the way you can tell they are characters is instead of just typing the number 1 in here, if this was a number that you could do arithmetic with, we've placed the 1 in single quote marks. And so that tells us that what we have here is actually not the number 1, but the character 1. And this is the character A. And this is the character star. And this is the character hashtag. So we have now an array of characters which can be accessed by choosing a pair of indices. So for example, if I said buttons of 1, 1, that would correspond to the second row and the second column, and it would be the character 5. All right, so we've now introduced the concept of arrays and multi-dimensional arrays, as well as byte and character type of variables. All right, now we're going to introduce yet another special type. We've seen bytes, characters, ints, and so on. We're now going to introduce a rather specialized type. And it's a type that didn't exist until we imported the library, the Keypad library. I'm going to type in the name of that type, and it's called Keypad. when I finish writing Keypad, you'll notice something interesting. The color changes from black to orange. That tells me that my environment recognizes Keypad as a special name, as a special type. And I can now define an object, I can define something of the type Keypad. So I'm going to go ahead and define my own instance of this thing called Keypad. And I'm just going to make up a name that I'll recognize. I'll call it my awesome pad. So my awesome pad is an object which is of the type Keypad. Now, I can go ahead and use that as I start to work with my Keypad. I'd like to set it up. And so in addition to just declaring my awesome pad here, I'm going to go ahead and I'm going to set it equal to something using the make key map function. That is a function that's available to me because I have included the Keypad library. So let's go ahead and set my awesome Keypad equal to the results of calling make key map, another recognized function, on this set of labels right here called buttons. So make key map buttons will now associate these combinations with these pins on the hero, row pins and column pins. And this is just telling make key map that it's 4 by 4, since rows and columns are each 4 dimensional. So that now has more or less taken care of everything we need to do in order to start to communicate with the Keypad. I now need to populate my setup and loop routines with some code that will actually do something. Now, what we're going to do in this exercise is we're going to read every time that a button on the keypad is pressed, and we're going to send that information out to the serial monitor. So as you'll recall from our earlier exercises, that means that in setup, we're going to need to begin or to start up the serial monitor. So just as we've done before, let's go ahead and insert that into our setup routine. So there we go. Setup now contains the serial.begin command running at 9600 baud, and that should be all we need. All right, now we'll get to sort of the main event. In loop, we will be constantly running over and over again a single line, not a single line of code, but sort of a single function. And this is what we're going to do. First off, we are going to create a new variable. This variable is a character, and the name of the variable is result. Just to remind me that what this is the result of checking the keypad. Result, every time we run through a loop, will be set to a value returned by myawesomepad.getKey. GetKey is one of the functions associated with this keypad, myAwesomePad. So when I call myAwesomePad.getKey, it will take the result and put it into this variable called result. Now, that's not of any use unless I can go ahead and now print that out, communicate it. So what I'm going to do, I'm not really interested in seeing a result if nothing happened, if nobody pressed a keypad. So I'm going to put in a logical test here. Instead of printing out 00000 constantly whenever nothing is happening, I'm going to put in a test. And the test is this. If result is non-zero, and that's really what it means here, is that if result is 0, then the result is false. But if result is anything except 0, then the result would come back true. If I wanted to make this a little bit clearer, I could actually explicitly put in here, say, if result is not equal to 0. And that would do the same thing as the code that we had before. But it's a nice shortcut to remember that I can just put in if result, and that's the same thing as saying if result is non-zero. If result is anything except 0, then print result to this serial monitor, and then just repeat this forever. So this is a very simple code. It has a test to see if result is anything but 0, and if it is anything but 0, we'll print it out to the serial monitor. We're almost ready to test. Before we actually compile this code and upload it to the Hero, wanted to do one more review here to make sure that we understand why we've selected the numbers that we did. As it turns out, as we talk about rows and columns on the keypad, by convention, the first row and first column are in the lower left of our keypad. So this one would correspond to row 1, column 1. This one would correspond to row 1, column 2, and so on. Now, that's fine. However, a conventional keypad, like one that you might find on an old-fashioned telephone, generally has the numbers starting in the upper left, not in the lower left. And so for that reason, you'll notice that in our code, we've chosen to have the column pins, 6, 7, 8, and 9, increase from left to right, because after all, if I'm looking at columns right here, and I'm looking at the top 4 pins, 6, 7, 8, and 9 are corresponding to columns 1, 2, 3, and 4. So that's fine. But for the rows, those should be reversed because we want to start at the top, not at the bottom. So if we look at our keypad again, we'll notice that row 4 is actually connected to the lowest pin, to pin 2. And row 3 is connected to pin 3, and so on. So that's why we have them increasing from the back, from 2, 3, 4, and 5. So if you don't understand that, maybe have a look at it yourself. And as you connect this circuit, if you try swapping the order in which these are connected, you'll see the change in the results when we press the buttons. Now, hopefully we've done it correctly here. And so we should be able to verify that our keypad is working as we intended it to. So now would be a good time to go ahead and check to see that our code is correct. We're checking it. Okay, we have an error, a syntax error. And I think I know what that syntax error is. Yes, we did not put a closed bracket at the end of our if statement. Okay, now we have a closed bracket at the end of our if statement and a closed bracket at the end of loop. So let's go ahead and test it again. Compiling, and it's good this time. All right, so if there are no other mistakes, we should be able to go ahead and upload the code and see whether we get the expected results in our serial monitor down below. So, uploading now. Uploading is complete. We're getting nothing right now on the serial monitor, which is to be expected because we're not pressing the keys. But now, if I press the upper left key, I should expect to see 1. There's 1. Let's go the next one to the right. There's 2. Let's go down in columns. The second one in the first column should be a 4. And I can check the others. The lower right corner, according to our assignment, should be a D. And the next one to the left of that should be a hashtag. So it looks as though we have succeeded in reading our keypad using the keypad library functions, and we've written some code that, at least in a basic way, makes some decisions based on what has been pressed or not pressed on our keyboard. Next time, we'll build on this knowledge and figure out ways of actually doing something useful from a standpoint of enhancing the security of our data and communications. And so, until next time, remember, build everything and invent safe.